Solve this DE using annihilators. Here is the original problem. I first find y sub c. I found my auxiliary equation and I set it equal to 0. I factored and I solved. I got two unique real solutions. My y sub c is c sub 1 e to the negative x plus c sub 2 e to 3x. We now need to find our y sub p. What annihilates a 4 e to the x minus 9? Remember, we have three patterns. And this is pattern 2, this is pattern 1. So what annihilates a 9? A D does. That was case 1. What annihilates a 4e to the x? That's e to the alpha x. That's case 2. What annihilates that? That would be d minus 1. You set that, if you find your auxiliary equation, which is m minus 1 equal to 0, and you get m equals 0 and m equals 1. Always look back and see if either one of these roots showed up in the y sub c. If it did, you would have repeated factors and you'd have that variable x. Remember that? But it doesn't. So my y sub p is going to be c3 e to the 0x plus c4 e to the 1x. And that's y sub p equals c3 plus c4 e to the x. And what we do is we go back and we look at our original equation and we see that there are highest derivatives 2. So take your y sub p and I want you to find two derivatives. So y sub p prime equals c sub 3 goes away, c sub 4 e to the x, and y sub p double prime is the same thing, c sub 4 e to the x. I'm just taking the derivative of the right-hand side. All right, so what we do now is plug those back into the original. Y double prime, let me write my original down here. Y double prime minus 2y prime minus 3y equals 4e to the x minus 9. Keep in mind we're finding the particular solution. So y double prime is going to be here, c4e to the x minus 2 times y single prime, y prime, which is c4e to the x, minus 3 times y, which is my y sub p. That's going to be negative 3 times c sub 3 plus c sub 4 e to the x equals 4 e to the x minus 9. So this is c4 e to the x minus, well, you know what, we can go ahead and combine those because I'm running short on room. So let me erase that. So combine the first two and that gives you negative c4 e to the x, because there's a 1 minus 2 is negative 1, minus 3 c3, I'm distributing that minus sign, minus 3 c4 e to the x equal 4 e to the x minus 9. And I can combine these, and that gives me negative 4 c sub 4 e to the x minus 3 c3 equals 4 e to the x minus 9. So this is like partial fractions. You see you've got this 4c sub 4, negative 4, on your e sub x, and here you have a 4. So I know that this piece, we're trying to find c sub 3 and c sub 4, by the way. I know that minus 4 c sub 4 has got to equal a 4. And that tells me that c sub 4 is going to equal negative 1. Now, I know that this is a constant and this is a constant. So negative 3 has got to equal a negative negative 3 c sub 3 has got to equal negative 9. Let me write that again. You can't read that. Those constants, I'm setting those equal to each other. I know that negative 3 c sub 3 has got to equal negative 9. That means c sub 3 has got to equal positive 3. So my y sub p then equals, here it is, guys. Y sub p equals, what is c sub 3? It's 3. What is c sub 4? Negative 1, negative e to the x. So I'm running out of room. I'll squeeze it in down here. Your final solution is going to be y sub c plus y sub p. So c1 e to the negative x plus c2 e to the 3x plus my y sub p plus 3 minus e to the x. There's my solution.